Hello student, let's see the question number 20. Very simple question. For a decomposition reaction of azio, azoisopropane to hexane and nitrogen at 543 Kelvin, the following data are obtained. Calculate the rate constant. Here the temperature they have given and here is the pressure. So when the temperature, this is not the temperature actually, it is the time in second. So when the time is 0 second, the pressure was observed, initial pressure 35. When time was 360, then pressure was 54. And when time was 720, the pressure raised to 63. So calculate the rate constant. Okay. So what we have to do is, student, first of all you frame the equation. What they are, hexane and nitrogen gas is evolving. So suppose this is the nitrogen gas and hexane is C6H14. So azoisopropane, what is the formula of azoisopropane, student? This is the N double bond N, and isopropane you are writing, student. So it is the what, CH3, and this is CH3, and this side also it is going to be CH. Here is CH3 and this is CH3. This is what, that is isopropane. Up when the time T is equal to 0, so initial pressure will be Pi. Here is nothing because the no product form when time T is equal to 0. T is equal to T equilibrium you are going. So what is going to happen? Suppose it is forming the X and it is also going to form X because the coefficient is the same. 1 coefficient is there. So what will be remaining here? So Pi minus it is X. So Pt is equal to total pressure is what? Sum of partial pressure. Sum of partial pressure. So sum of partial pressure of all what will be there? Pt is equal to what? Pi minus X plus X plus X. This is minus X plus X will be cancelled out. So Pt is equal to Pi plus X. This is question 1. Now you see here is the T equal to 0. So if we are supposed to get the P azoisopropane, isopropane means pressure of azoisopropane at time T, at time T. So at time T what is there? So P azoisopropane is equal to what is? Pi minus X. They have given this one, Pi minus X. From here we can calculate the X also. X is equal to what is there? Pt minus Pi. We can put this value here. So P azoisopropane is equal to what is there? Pi minus what is there? Pt minus Pi. If you solve this one, P azoisopropane is equal to Pi minus Pt plus Pi. So P azoisopropane is equal to 2Pi minus Pt. So initial pressure is this one and final pressure is this one. So you can put the value equation. So K1 you calculate K1 at 360 degree, 360 second, rate constant at 360. So K1 is equal to, it is going to be 2.303 upon what is T log initial, that is Pi, upon 2Pi minus Pt. So what is there? 2.303 upon T, how much is there? You have to consider 360. This is, we are considering 360. Log Pi, how much there? 35 initial pressure. So 2 into 35 minus Pt, how much is there? 54. If you are writing this one little bit more, so 2.303 upon 360, here you are calculating log 35 upon 35 into 2, that is 70 minus 54. So 2.303 upon 360, here is log 35 upon, if you are subtracting, this is going to be 16. So log A by B, so log A minus log B, it will be there 2.303 upon, it is going to be 360 log 35 minus log what is there, 16. So now we need to put out the value. So 2.303 upon 360 log 35 value you can check from the table. It is the 1.544 minus 1.204. Now what we can solve this one, 2.303 upon 360, here is coming 0.34, this is there. So now the answer is coming how much, student? 0.00217. This is going to be second one, inverse. Or you can even write 2.17 into 10 power minus 3. This is second inverse. Okay, this is the K1. Now we can calculate K2 also. K2 at how much? 720 second. Because here they have given another data, this one. This data we can use. So what we can use? 2.303 K2 is equal to 2.303 upon this is T log what will be there? Initial, that is Pi upon 2 Pi minus Pt. Now you can plug out the value 2.303 upon T 720. This is the 720. This is the log. Initial pressure already given 35. And here is the 2 Pi 2 into 35 and Pt they have given how much, you can see this is 63. So here is 63. So how much is coming? 2.303 upon 720 log 35 upon 70 minus 63. So what will be there? 2.303 upon 720. It is going to be log 35 upon it is coming 7. So it will be 5. 2.303 upon 720 log 5. Log 5 value you know already, 2.303. 720 log 5 value 0.699. So what if you are solving this one, it is coming, student, 2.236 into 10 power minus 3. This is second inverse K2. So you can use either this value or this value, or K average K you can calculate, average K, average rate constant if they ask. So average rate constant means what? K average equal to K1 plus K2 upon what is that? 2. K1 value you can write here. What is there? 2.17 into 10 power minus 3. 2.17 into 10 power minus 3 plus how much is there, student? This one, 2.236 into 10 power minus 6 divided by 2. So if you solve this one, so it is coming 4.411 into 10 power 3 here, 3, this is 3, sorry, here is the 3 only, 10 power minus 3 upon 2. So if you solve this one, 2.20 into 10 power minus 3. This is the K average, this second inverse. So this is our required answer, student. So this is the K1, K2. Firstly, you will face the problem here. P, okay, in the rate constant what we take, student, it is only for reactant. So you should know the value, this one Pi and this is Pi minus X. So X value you need to find out. So X value we can find from this equation. Pt is equal to Pi plus X. So X is equal to P2 minus Pi. Then you plug in the X value, then you will get this equation. After that it will be very easy. Thank you very much for watching.